Imagine a place where the sky can turn green, the air feels electric, and within minutes, a calm, sunny day becomes one of the most dangerous weather events on Earth. That place is known as Tornado Alley, the stretch of the United States that produces more tornadoes than anywhere else in the world. But here's the big question: why here? Why do tornadoes seem to favor this one part of America over all others? Today, we're breaking it all down. By the end of this video, you'll understand exactly why Tornado Alley exists, how geography and weather patterns team up to create the perfect storm, and why scientists are rethinking the boundaries of Tornado Alley today. The geography of Tornado Alley. At its core, Tornado Alley is all about location. Traditionally, the term refers to parts of the Great Plains region, stretching through states like Texas, Oklahoma, Kansas, Nebraska, and South Dakota. Some maps also extend it east into Iowa and Missouri. Why this area? Geography. The Great Plains is a huge flat stretch of land with very little to block or disrupt large-scale weather patterns. Unlike mountainous regions that can break up storms, the plains give weather systems a wide, open runway to develop and intensify. The openness of the land allows three very different air masses to collide right here: warm, moist air from the Gulf of Mexico, cold, dry air from Canada and the Rocky Mountains, hot, dry air from the desert Southwest. When these collide, it's like mixing explosive ingredients in a giant natural laboratory. The role of the Gulf of Mexico. The Gulf of Mexico plays a huge role in why Tornado Alley exists. This warm body of water sends moist, humid air northward into the plains. Tornadoes need moisture to fuel the thunderstorms that create them, and the Gulf is like a never-ending supply line. Without the Gulf, the interior US would be much drier and less storm-prone. But with it, the plains are constantly supplied with the warm, sticky air that sets the stage for severe weather. Cold, dry air from the north and west now add the opposite ingredient: cold, dry air sweeping down from Canada and the Rocky Mountains. This air mass is dense and heavy, and when it crashes into the warm Gulf air, it forces the lighter warm air to rise. That upward motion is the spark thunderstorms need to form. This collision happens most often in spring and early summer, which is why tornado season peaks in April, May, and June. During this time, the jet stream, a high-altitude river of fast-moving air, also dips southward into the US, helping fuel storm systems even more. The desert Southwest roll. The third ingredient comes from the desert Southwest, where hot, dry air pushes in from New Mexico and West Texas. When this hot air slides over moist Gulf air, it creates a sharp boundary known as a dry line. The dry line is like a trigger. Storms love to form along it, and many of the strongest tornado outbreaks in Tornado Alley have started right where this boundary sets up. The perfect recipe for supercells. So we've got warm, moist air, cold, dry air, and hot, dry air colliding. But tornadoes don't just pop out of every thunderstorm. The most dangerous ones form from a special kind of storm called a supercell. Supercells are rotating thunderstorms. They form when strong wind shear is present. That means winds are blowing at different speeds and directions at different altitudes. For example, surface winds might be blowing from the south, while winds higher up in the atmosphere blow from the west. This difference creates a horizontal spin in the atmosphere. When strong updrafts from thunderstorms tilt that spin vertically, you get a rotating storm. Inside that storm, if conditions are just right, a tornado can drop. And Tornado Alley is basically the world's biggest factory for producing these supercells. Why the US dominates tornado activity? Now you might wonder, why doesn't every country with flat land and thunderstorms have its own Tornado Alley? The answer is geography again. The United States is uniquely positioned. To the north, there's a massive source of cold air in Canada. To the south, the Gulf of Mexico provides endless warm moisture. To the west, the Rocky Mountains block Pacific moisture but also help funnel cold, dry air downward. To the east, there's no mountain range stopping the warm, moist air from flowing deep into the continent. Few other places on Earth have this perfect combination. That's why the US has more tornadoes than the rest of the world combined. The historical origins of Tornado Alley. The phrase Tornado Alley actually comes from the 1950s, when researchers began studying tornado activity in the Great Plains. Over time, the name stuck, and the region became infamous for its twisters. Towns in states like Oklahoma and Kansas even hold storm chaser festivals today, embracing their identity as part of Tornado Alley. Tornado Alley is shifting. But here's something surprising. Modern research shows Tornado Alley isn't fixed. In recent years, tornado activity has been shifting eastward into states like Mississippi, Alabama, and Tennessee. Some scientists now talk about Dixie Alley. Why is this happening? Climate change may be playing a role. Warmer air holds more moisture, which could be fueling more violent storms further east. But it's not just climate change. Population growth in these states means more people are exposed to tornado risk. So we're noticing the storms more. Still, the traditional plain states remain at the heart of America's tornado activity. The human impact Tornado Alley isn't just a science term. For people living there, it's a way of life. Towns build storm shelters, schools run tornado drills. Local weather stations have some of the most advanced radar systems in the world, because seconds of warning can mean the difference between life and death. Despite the danger, millions of people call Tornado Alley home. And while many residents respect the storms, others see them as part of their culture, even chasing them for science, photography, or adrenaline. Famous Tornado Alley disasters. Over the decades, Tornado Alley has been home to some of the deadliest and most destructive tornadoes in U.S. history. The Tri-State Tornado of 1925, which tore through Missouri, Illinois, and Indiana, killing nearly 700 people. The 1999 Moore, Oklahoma tornado, which set a world record for wind speeds at over 300 miles per hour. The Joplin, Missouri tornado in 2011, which killed over 150 people and destroyed thousands of buildings. Each of these events highlights why Tornado Alley remains such a focus for scientists and emergency planners. The science of prediction. One of the most important reasons we study Tornado Alley is prediction. Tornadoes are notoriously difficult to forecast, but advances in radar and storm models have improved warning times dramatically. Back in the 1950s, people often had no warning at all. Today, the average lead time is about 13 to 15 minutes, and in some cases, even longer. Scientists use Doppler radar to detect rotation inside thunderstorms, giving communities critical time to take shelter. The future of Tornado Alley. Looking ahead, scientists are asking tough questions. Will Tornado Alley remain in the plains, or will the center of activity continue shifting eastward? Some studies suggest climate change could make storms more intense, but not necessarily more frequent. Others warn that increasing populations in tornado-prone areas mean that even if the number of tornadoes stays the same, the damage could be worse. Whatever the future holds, one thing is certain: Tornado Alley will remain a key area for research, preparation, and survival. So why does Tornado Alley exist? It all comes down to geography and weather patterns. The perfect collision of warm Gulf air, cold Canadian air, and dry desert winds, all meeting on the flat stage of the Great Plains. Add in strong jet stream winds, and you've got the recipe for the most powerful tornadoes on Earth. Tornado Alley isn't just a line on a map. It's a reminder of how powerful nature can be and how much we still have to learn about the atmosphere above us. Thanks for watching. If you enjoyed this breakdown of Tornado Alley, make sure to like, subscribe, and stick around for more deep dives into the mysteries of our planet's weather.